did combining like terms, right? So we had things like 2x plus 3y minus 4x minus 7y, and we combine them, right? So we combine our x's. So if I have 2 x's and I take away 4 x's, how many x's do I have?
Negative 2x.
I have negative 2 x's. Not quite sure what that looks like, but that's what they have. And then if I have 3 y's and I take away 7 y's, what's that going to look like?
Negative 4.
Negative 4 y's. Okay? So today we're going to be using some of our distributive property things with combining like terms. So I want you guys to think back to our M&M's machine yesterday, except it's filled with x's and y's. So if I sit the thing, right, and I get an x, and then another x, and then another x, and then a y, and then a y, and then a y, what does that give me? How do I write that easier, Tallulah?
You could do 3x plus 3y.
3x plus 3y. Now, is that any different? Remember when it was only spitting out like 2 things at a time?
Yeah.
So it's only spitting out like 2 things at a time, and I hit it once, and it gives me an x and a y. So I'm going to hit it again because I want more than 2 candies, and I hit it again, and it gives me an x and a y. And I hit it a 3rd time, and what does it give me?
An x and a y.
An x and a y. So I did it 3 times, and it gave me an x and a y.
It's the same thing as that.
It's the same thing. Now, I'm going to do this a little bit organized, though, so I don't forget anything. I know that I got an x 3 times. If I get an x 3 times, how many x's do I have?
3.
So that's 3 x's. And if I got a y 3 times, how many y's did I have?
3y.
3 y's. So getting 3 x's and 3 y's isn't any different than getting x and a y 3 times,
No.
right? It's the exact same thing. Okay, so that's distributing with this same thing. What if I have, give me a number, yeah.
Oh, I was reading my hand because I didn't get a problem.
You didn't get a problem.
Yeah. I was wondering if you could do it on the board.
Oh, on yesterday's assignment?
Yeah.
Yeah, let's backtrack. What problem?
Number 11b.
Okay, tell me what it is.
The total length of a string and a stick is 15 meters long.
Is what?
Is 15.
No, it isn't.
Length
No, it isn't.
string and the stick is 15 meters long.
Length of the stick and the string.
Mrs. Barlow, Mrs. Barlow.
Yeah.
You spelled length wrong. You forgot a T.
Yes, I did. I'm on the board. Okay. It's 15 meters. So the length of the stick and the string is 15 meters. How long is the stick?
4 times as long as the stick.
4 times as, wait, how long is the stick?
4 times as much as the string.
Okay, the stick is not 4 times as long as the stick.
The string is 4 times as long as the stick.
The string is,
The stick is 4 times as long as the string. No. The stick. No, the string is. The string. Oh. Yeah, the string is 4 times as long.
how long is the stick?
It's the remaining.
How long is the stick? X.
Wait, what?
Look at the one above it. Look at problem 10. How long is the stick?
It says to express the length of the string in terms of, like, oh my god.
Look at it and tell me how long the stick is, Zach. X.
My brain is dead.
So this is where we have a lesson in reading the problem. How long is the string?
4 times.
4 times X. So the string is 4 times as long as the stick. And we know that both of them together are 15 meters. So how would we express both of them together? What math operation is that? What was that?
5x.
on, what math operation are we doing?
Addition.
We're doing addition. So stick plus string is 15 meters. Now you guys just told me it was 5x. You just told me that x plus 4x is 5, which it is. 5x. 5x equals 15 meters. I have a number multiplied by a variable. How do I undo multiplying? Matthew, please stop. How do I undo multiplying?
Division.
Division. So I'm going to divide by 5. Divide by 5. So I get that x equals 3 meters. Now, is that what I'm looking for? Am I looking for the length of the stick?
No.
What do we want?
The
The length of the string, which is 4 times the length. So 4 times 3 meters. And the string is 12 meters long.
I put that, but you said it was wrong.
Did I? Did you put that?
I didn't put the units, but you made it look like I did my math wrong.
Oh. Well, then you need to hand it back in, and my apologies. So, okay, we're all good on this one? Some of you told me that the string is 60 meters long, which is remarkable. Yeah, which is remarkable because the whole thing together is only 15. That is an example of not reading the problem and just looking at the 4 and the 15 and going, oh, I can do 4 times 15 and slooping down the answer of 60 and not reading. Yeah.
I'm extra vulnerable to the dark zone today because
That's all right.
I need sleep.
Okay, dork sounds happen, so it's all good. So let's go back to today's stuff. Any other things from yesterday's that killed you?
My brain.
Your brain killed you yesterday? It's all right.
Yeah,
Brains kill us sometimes.
I saw the whole thing.
Okay, so this is multiplying. Should we do another? Let's do another one. Give me numbers.
Negative
Give me another.
34.
Okay, I like his number better. What?
Negative 5x.
Negative 5. Just reduce it to your number. Give me another number, kid.
72.
Oh, guys,
7.
I'm doing this math up here in my head. Come on, like throw me. Times 7x. Give me another number.
11.
Minus 11y plus 4. Oh,
That's.
can we do this?
Yes.
We can. Okay, this is where you're going to want to use your rainbows because you can keep track of stuff or else you're going to get confused.
What rainbow? That's fun.
This is a rainbow. Everybody gets a little piece of this 5. This 5 gets multiplied by everybody. Now, is this a 5?
Negative 5.
Negative 5.
But it's
Kids
so fun.
have a very hard time seeing negatives. They just vanish from the world. So make sure you see your negatives. What is negative 5 times 7x?
Negative 35.
Negative 35x. We have one negative, one positive. We're multiplying them, so it's going to be negative. So that's negative 35x. We have negative 5 times negative 11y.
55. Positive 55.
Positive 55. Do I need to write the positive sign?
No. Yeah.
Yes, because it's in the middle of a string here. The positive becomes a plus sign. See how that works?
Yeah.
If it was a negative, it'd be a subtraction sign. But we're adding 55 y's. That is a lot of y's. I hope that y's are something good like, I don't know,
Candy.
candy or something. I
Yeah,
hope it's
no,
not.
it's not
I hope that this is not bee stings and that it's like
That is
candy bars.
Why is one?
We don't know what y is. Y could be candy bars. It could be bee stings.
55. It could be murder. Pepto-Bismol.
Y could be Pepto-Bismol from eating the 55 candy bars. Okay, one more. Are we done? We're not done.
Negative 20.
Okay, negative 5 times positive 4 is what, Kessler?
Negative 20.
Negative 20, and that negative becomes a subtract sign. Okay, can we combine any of these?
No.
Can we combine the x's and the y's?
Yeah, because you can't.
We
combine
can't.
these
None of
things
them
or
are.
candies.
We can't combine. If x's are candy bars, and y's are bee stings, and that's just numbers, that doesn't math. Yeah?
I have a question.
I have an answer.
What if you have the 5 on the other side?
Okay, okay, so here's a question. Does 3 times 4 equal 4 times 3?
Yes.
Does it matter if the 5's on the other side?
No.
Yes.
No. I got it.
Yeah.
Wouldn't it? Because then it'd be -5, not you no longer.
Well, we would have to remember So when we have parentheses, and we should have put number right next to the parentheses, we don't have to put a multiplication sign there because we just know. But if we do it on the back side, if we have 7x minus 11y plus 4, and we multiply that times -5, if I just write -5 like that, that means I'm subtracting.
Yeah.
So, but if I do parentheses, bloop, bloop, what am I doing now?
Multiplying.
Multiplying. So, you have to just be careful. We can flip-flop their order all day long if we want
You
to,
have to modify the negative.
but we just have to make sure we're writing it carefully, right? Because it matters, especially once we start involving negatives. I'm going to show you one in a second here where we have some negatives involved. If you don't have your parentheses, or like if you put parentheses in where they don't belong, you're going to mess yourself up, okay? So what about if we could do this with multiplication, can we do this with
Division?
division?
Yes.
Yeah.
Let's do example 2. So we have 6x minus 15, and we have parentheses. Is it 15?
Plus.
Plus 15. Divided by 3. Now, I'm going to be real with you. I don't like doing it like this because I tend to forget. So here's how I like to do it. I like to write it divided by 3 and divided by 3. That way I remember everybody gets divided by this 3. Now, is this a positive 3 or a negative 3?
Positive.
Positive 3. So we're not going to have to think about the signs so much. So what is 6x divided by 3?
2x.
2x. So if I have 6 x's and 3 friends, how many x's does each friend get?
2.
2 x's. Let's hope that x's are candy bars. And then we have 15 divided by 3 is
5.
5. Is it positive or negative? Positive. Plus 5.
Strawberry. And is that it?
X to be
Clearly this would be great.
X to be
Oh, yeah.
So, are we done? Did everybody get divided by this 3? Now, I could do rainbows like that and do 6x divided by 3
It's just
and do 15
easier
divided
to
by
do that.
3.
It just doesn't
But
look right.
for me, I like it better that way. That's just kind of how my brain works. If your brain works like this, that's fine. I'm going to take my sweater off because I am warm. Okay. We ready for some more? Getting a little bit more challenging?
This is actually fun.
It's not bad. I like this stuff. You get in a good group. They do get a little more challenging though. So we're gonna do example 5, which I think is a little bit too easy to be an example. And then I'm gonna do one very similar to number 8 because it's a little more challenging.
Why do you have 6 examples?
Because it gets a little bit more challenging and a little bit more challenging. Also, there's like 2 examples per assignment, and I think we combined 3 assignments into this one.
8?
Maybe not. I don't know.
Wait, why did you just go from example 2 to example?
There's only 6 examples.
Because I deleted examples 3 and 4 and didn't renumber them.
Wait, which example did you say you did?
We're gonna do example 5.
Okay.
Okay?
Wait, that's simple.
That is super simple. So then I'm gonna do one that's a little bit harder. So what if I have 4 times x plus y? Can I do this with more variables in there?
Yeah.
This is jelly beans and M&Ms and
Twizzlers.
Twizzlers.
You can do all.
We're not okay. So no. Okay.
Aww.
So let's use our rainbows. What's 4 times x? 4x. What's 4 times y? Oh my gosh, this is too easy. What's 4 times z? Let's do one that's a little bit more challenging.
I have a question.
Yes.
Can you have a variable that's more than 2 letters?
Okay, if you have a variable that's more than 2 letters, what that means is if we have, let's say we have a variable that looks like this, x, y, z, this really means is x times y times z.
Ooh, so
So if x is 2 and y is 3 and z is 4, we have 2 times 3 times 4, which is 24. Okay. Will you encounter variables multiplied by each other in your future?
Yes.
Yes. Will you encounter variables multiplied by each other today? No. Yes.
Can I take a nap?
No. When I am done teaching you and you're done with your assignment, yes.
Can we get buried by murder?
You can, but it's not a good life choice. Okay.
What's a better one?
Not getting buried by murderers.
Alive or dead?
Okay, let's oh, we're gonna dance.
Kylie Fuller, come to the office for checkout. Kylie Fuller.
Okay, so this one's gonna be.
Please come to the office. Kel Paletta.
Oh, you weren't finished. Okay, give me numbers that are less than 10. Between -10 and +10. Negatives are on the board here. Isaac.
-5.
Whole numbers, integers, greater than or equal to -10, less than or equal to +10, and not equal to 0.
-9.
-9. Okay, hang on. -9. Give me another one.
7.
Give me another one.
4.
-10. 9.
Which one's
-10.
Okay.
Again.
Variable C.
No, that's not an integer. Greater than or we don't know what C equals. Yeah.
9.
Yes.
You all are not good at understanding instructions.
Wait, I have a guess.
3x.
9.9999.
No, that's not an integer. Actually, 9.9 onto an infinity is an integer. That equals
Wait.
10.
Can we do infinity?
Is that an integer that's greater than or equal to -10
not
and
a
less
math.
than or equal to
It's
10?
not even a number.
It's not even a number. It's a direction.
It's 8.
No,
9.
we have this. Let's do this.
Sideways 8. Sideways 8.
Do you want to have time to work on your assignment?
I already did.
No.
I know, but you need to be respectful of the other people in the class. Okay. So let's do what is. First of all, okay. There's a lot going on here. We have stuff inside of parentheses. We have multiplication of the stuff inside the parentheses. We have subtraction. We have more parentheses, more multiplication. Where in the world do we start?
At the beginning.
What does PEMDAS tell us to do?
Parentheses.
Can we combine any oops. Can we combine any like terms in these parentheses?
No.
We could a second ago and then I fixed it.
Both of them.
No, we can't combine any like terms in the parentheses. So what do we do next? Exponents. Are there any exponents?
No.
Off the hook.
We can divide. Wait, we can multiply.
We can multiply. Is there any division? No division. So we'll multiply in order left to right. Yeah.
What about 4y and 3y?
Okay, so those are in the parentheses. We need to deal with the parentheses first. We need to get rid of the parentheses before we can't add these two together. Adding and subtracting is the very, very, very last thing that we do. But we're going to multiply and divide in order from left to right. So we have -9 times 7x. What is that? Y'all people gave me these nasty numbers. What?
-63x.
-60. If y'all are going to give me nasty numbers, y'all have to help me figure out the nasty
Those are
numbers.
very nasty.
They're not very nasty, but everybody's suddenly super quiet. You're giving me like fractions and crap. Okay, what is -9 times -4y?
36y.
What flavor, positive or negative?
Positive.
So we have negative.
No.
That's not strawberry. That's not a flavor option for numbers. Negative times negative gives me a positive
36y.
36y. Now, I'm not going to write this subtract sign. I'm going to hook it onto this 10 because I'm multiplying by -10. Okay? So -10 times 5x is -50x. Negative 10 times
Negative 30x.
negative 30y.
Y.
Okay, so can I math this?
Yeah,
Woo, these are big. So I'm okay, am I done with all my multiplying?
Yes.
Okay, PEMDAS says add and subtract in order from left to right. What is negative 63x minus 50x?
113x.
What flavor?
Negative.
Negative
I'm
113x.
the only person who said the answer, so.
I know everybody else
I'm
is
not
busy
gonna say
working on their
anything this time.
assignment.
What else is
Positive 36y minus 30y. How many y's do I have?
6y.
6y. Positive or negative?
Yeah.
Positive
What was that?
6y. And I end up with negative 113x plus 6y. You guys see how that goes?
I did everything except for the 6y. And that was mixing.
Okay, should you guys see how this negative, when we're multiplying, we multiply the negative by all of that. Now, you guys ready to see one more? This one's
no.
gonna be, those of you who are working on your assignment and ignoring me, you need to stop right now because I'm showing you stuff that you're probably gonna mess up on if you're not paying attention, okay? There's a reason I'm showing you this stuff. What if I have this? What if I have 4x plus 3y minus 3x plus 4y? 3x minus 4y. All right.
Nightmares.
Do I have any multiplying that I need to worry about?
No.
No, we're just subtracting, but we're subtracting this whole thing. Can I just pluck those parentheses off of there? No, I cannot. I need to pay attention. Yeah.
Oh, I was gonna say like maybe there's something that you could do to solve it.
Okay, we need to give this negative everything that's in here. So this is a positive 3x. What is this negative going to do to it, Zach?
Make it negative.
It's going to make it negative. So I can take that off right there. And then I have a negative 4y. So what's that going to do? It becomes positive 4y. Do you guys see how that works? Now I can take the parentheses off.
Oh.
Now I can just do this. But I dealt with that negative and I dealt with the parentheses. So what is 4x minus 3x?
1x.
1x. Do I need to write the 1? Yeah, no. What is 3y plus 4y? Plus 7y. Do you guys see how we did that?
Yes.
Now, I could have left that there and left these with those signs, and then I go 4x minus 3x is x. 3y minus a negative 4y is 7y. You do whatever works for you in your brain. If you want to rewrite it with that negative all the way through, that's fine. Or if you want to remember that it's there. But remembering that this negative is there, it changes the sign of everything in that parentheses. Okay, yeah.
So for something like on the last page, it says something about what is the opposite of negative 60 plus 1.
Okay, let's say we have, let's say we have 4s minus 2. What is the opposite of that?
Would it be negative?
Okay, when we have the opposite of something, we can put a negative sign in front, and there we have the opposite. What's the opposite of 5? Well, negative 5. What's the opposite of negative 21? Well, negative 21, and then it becomes positive 21. One of my algebra teachers way back in the olden days said, when you have variables, the negative sign, you can look at it as a negative, but it also means the opposite of. This is the opposite of x. If x is positive 4, then the opposite of x is negative 4. But if x is negative 7, the opposite of negative 7 is positive 7. And it's kind of an easier way to think of it. Yeah, Isaac.
Did we do problem 10 on the board?
No? Oh, we haven't gotten to that part yet. The factoring part. Let's do some factoring. I'm going to do the example right above it, and then you can do 10 by yourself. So let's do some factoring. As I recall, you guys don't like factoring, right? So let's pretend we have 72t plus 8. What is the greatest common factor of these two?
8.
8. We can divide 72 by 8, and we can divide 8 by 8. So we're going to pull out an 8. What is 72t divided by 8?
Oh.
9t, not 90, but 9t. And then what's 8 divided by 8?
1.
1.
That's
What if we have something nastier? Should we get something
I
nastier?
don't want to do something nastier.
Ah, no one's not nastier.
Yeah.
Darn it. I don't like nasty stuff.
All right. Nastier. As I fall. Okay. What's the greatest common factor here? Zach, you participated a lot. Let's let Gentry have a turn. Gentry, what's the greatest common factor? We can pull a 15 out of all of these. So what is 15x divided by 15?
1. X.
Just x. What's 30y divided by 15?
2y.
What's negative 45 divided by 15?
3.
Minus 3. And then we have that. This is really, really handy when you're dividing. Let's say we have 15x plus 30y minus 45, and that's all divided by 15. You factor that 15 out, and you have 15 divided by 15, and boop, boop, they go away. So that's handy when you're doing those things. I know you guys hate factoring, but it is handy.
I like factoring.
I love that you like factoring. Some of the other, look at Kinsley's face. You can see how she feels about, she doesn't like factoring.
like factoring. It's not fun. It's fun.
If you are good at seeing the greatest common factor, factoring can be fun. If you're not good at seeing the greatest common factor, factoring can be a giant pain in the butt. Like on this one. Let's pretend that you didn't see that it was 15. And you look at that and you go, 5.
That's what I did.
5. Okay, so we have 5. What's 15 divided by 5?
3x.
Where's 3x. What's 30y divided by 5?
6y.
6y. And then 45 divided by 5?
9.
So now we look at this again and we go, oh, they all have another common factor. What's their common factor? 3. So now we pull out a 3, but what's 3 times 5? 15. And now we have our 15. And then, see how that goes? So if you're not good at seeing the greatest common factor, get a little factor, pull it out. But then you have to look again and go, did I miss something? And the smaller the numbers get, the easier it is to see their common factors. 3, 6, and 9, I think it's easier to see that they have a greatest common factor of 3 than 15, 30, and 45, right? I think so. Okay, are there any other examples we forgot? I think that's all of our examples. How are we feeling?
Good.
Feeling good?
Horrible.
Okay. Everybody, if not Zach, how are we feeling? If you're not Zach and you're not Nixon, how are you feeling?
Pretty good.
Feeling pretty good? This table's still beefy.
I'm